What's up, math scholars? We are about to do our 10-1 to 10-3 study guide video. The quiz is Wednesday. It is open note. It will be the last quiz of the year. So that's pretty good news, right? Who is excited to learn about math? Not everyone's looking excited. All right, number one, it's a cosine graph. The first thing we want to do is identify the amplitude, or how high and low it gets. It's the A value. Anyone think they know? It's 1. Very good. It's actually an invisible one that was right about here. The period formula is 2 pi over b. Does anybody think they know the b value? 2 pi is correct. So 2 pi over b, the b is this 2 pi right here. 2 pi over 2 pi, that's going to work out and cancel and just be a 1. So actually, this will be a very, very easy number line to label. All right, next up, we are going to talk about how I can take that period and label my hash marks accordingly. If you do not label all hash marks, you will lose points. You're getting points for labeling these correctly. What you do is you go out 4 hash marks, and this guy will be your period. So this is your 1. You cut that number in half, and that will be this hash mark. What would it be? 1/2. Very good. You cut it in half again, and this will be this hash mark. What would it be? And then this is the one people struggle with. You just have to triple the first hash mark. So you take the 1/4 and you triple it by multiplying by 3 over 1. What's 1/4 times 3 over 1? Very good. That's how you get the third hash mark. Now it's a cosine graph with an amplitude of 1. So the highest it will get is 1, and the lowest it will get is -1. Do you remember what the shape a cosine graph makes? It's like a big bowl. It starts high, drops to 0, goes down to the valley, back to 0, and finishes up at its highest point, which on this is 1. And you graph it with a nice smooth curve. And then you answer your domain and range questions. -infinity to infinity, and -1 to 1. Hello, math scholars. We're going to do number 2 next. What do you think the A value or the amplitude is? It is. What a scholar. All right, this one's a little bit trickier. The period is 2 pi over b. So you have to do 2 pi over 1/4. How can you divide by a small fraction like that? No, not really cross multiply. I think I know what you mean, though. Multiply by the reciprocal. Multiply by the reciprocal. So the period is 8 pi. Did anyone's group figure that out without my help? Yay! All right, so this is the weirdest part. You're going to go out your 4 hash marks and label that your period. Cut it in half. That would be your halfway point. What, or your second dash mark. What is 8 pi cut in half? Cut it in half again, and then triple the 2 pi.
6 pi.
All right, sounds like you know what you're doing then. Yeah. The amplitude is 3, and this is a sine graph. Sine graphs have different shapes than cosine graphs, of course. Where do sine graphs start? Now we have to go up 3 hash marks. I'm not sure why I only have 2 hash marks for you, so fix that issue. Go up to your mountain peak at 3, back to 0, down to your valley at -3, and back to 0. And that's going to be your shape. Now, somebody today was like, Mrs. Harp, how can I graph this in my calculator? You can. You want to make sure you're in radian mode. It's going to help you see the picture, so that would be nice, but it's not going to help you figure out how to label the hash marks necessarily. It's looking like I have an x-intercept at 0, 4 pi, and 8 pi. There would be more if I continue. And it looks like my y-intercept is at 0, 0. Alrighty, let's give number 3 a try. With tangent, the period is a different formula, so don't forget about that. On tangent, your period formula is pi over b. Now, do you know what my b value is? 2 pi. The pi's can cancel, and your period's going to end up being just a regular 1/2. There will be no pi's in your period. The pi's will cancel. All right, do I label anything on this picture with that 1/2? No. What you want to do is cut the period in half, and that would be your asymptotes. So if I cut 1/2 in half, it's 1/4. You do have an asymptote at positive 1/4 and at negative 1/4. I'll just write plus or minus 1/4. Plus or minus 1/4. Next, you're ready to do your halfway point. You cut your 1/4 in half, and that'll be an 1/8 and a negative 1/8. Now, halfway point is an actual coordinate. It's 1/8 comma a and negative 1/8 comma negative a. Do you know what your a value is on this problem? 3. Yep. So at 1/8, you'll go up to 3. At negative 1/8, you'll go down to negative 3, and those are your halfway points. Don't forget, all tangent graphs have a point at 0, 0, and you're ready to connect your dots and make a snake. Now, sometimes I'm really terrible at drawing these. You want to make sure your arrows are going to the ceiling and down to the ground and not looking like they're going to cross through the asymptote. So I'm sure you can make a better drawing than I just did. Try your best. Let's give number 4 a try. This is our first one that's got a translation to it. When you have the parentheses, it's going to make it the opposite of what you expect. What do you think the horizontal shift is?
0.
Nope. It's 0 for vertical shift. There's no vertical shift. It's not 0 for horizontal. You're close. It is pi units, but it's going to be to the right. Because of those parentheses, if your eyeballs are seeing the minus pi, it's actually a right shift. We're going to go ahead and figure out our amplitude and period so we can get things numbered. Your amplitude is going to be a 1 because it is absolute value of the a value. So that's just going to be a 1. And your period is 2 pi over b. Do you guys know what the b value is? It's right here. It's a 1. So we're going to label, this is those problems where if you remember last week, we did a preliminary graph with a light dotted line. Then we shifted it and made our final answer. That's what we're going to do on this. So I'm going to do a preliminary graph before the shift. It's going to look like this. It'll have a period of 2 pi. Cut that in half to get pi. Cut it in half again to get pi over 2. And triple it to get 3 pi over 2. It's a normal cosine graph. But it's upside down cosine graph. So it's actually going to start low, head up to the mountain peak, and come back down. So this is my upside down cosine graph before the shift is applied. Of course, we have to shift everything pi units to the right. How far is pi units based on what you're seeing? 2 hash marks? I agree. So that would make this 3 pi here. Every pink dot you see, I'm going to shift 2 units to the right and make a blue dot. So this one will now be here, shifted to right. This will be here, shifted to right. This will be here, shifted to right. This will be here, shifted to right. And this will be here. Now, oh, I messed one up. Oh, it was this one. This one wasn't supposed to be blue. This was supposed to be pink. I don't know what I was doing there. All right, now we're good. The blue line is my final solution, but I do not like when lines start in outer space right here. I like when they start touching an intercept. So I'm going to continue this trend and figure out that my intercept would be up here at 1. It just looks nicer if you have the intercept touching and labeled. Not labeled, but touching. We decided to power through and see if maybe we can finish this video in 1 class period. Number 5, what do you think the amplitude is? It is 3, okay. The period is 2 pi over b. So 2 pi over pi, the pi's will cancel, the period's 2. That'll make the numbering very easy. I like that. Do you think there's a horizontal shift? Nope, because there's no one in parentheses. Do you think there's a vertical shift? Yep, up 2. So I'm going to do the same thing with that preliminary graph and then shift everything and then have a final graph. Let me start by labeling my axis, my x-axis. My period is 2. This will be 1. This will be a half. And this will be 3 halves, or 1.5. It's a sine graph with an amplitude of 3. This is my preliminary graph. I'm going to make it light and dotted. I can't really make it light with a smartphone, but you can do that with your pencil. Everything will shift up 2. So purple will be my final answer. This was at 3, now it's at 5. Maybe I'll just put a 5 here to remind myself. This was at 0, now it's at 2. This was at -3, now it's at -1. Put that there to remind my brain. So this is not asking for domain and range, but I'm going to put domain and range just for the practice. Domain, -infinity to infinity. Range, -1 through 5. It's because that up to shift, that shifted it. The purple is your final. The purple is your final solution. Number 6 should be super easy. We need to translate up and to the right. So let's talk about what would do that. Your right-left number is in parentheses. Your up-down number is on the right. So there's your up 3. Now, if I want to go right pi, would I do x plus pi or x minus pi? Very good, because the parentheses cause it to be opposite of what you'd expect. So that would be right. Another tangent graph. All right. This doesn't have any right, left, or up, down shifts. This is a straightforward, easy tangent graph. The period is going to be pi over b. The pi's will cancel, so it's just a 4th. That makes your asymptotes plus or minus 1/8. And your halfway points half of 1/8. So 1/16, comma, a, and -1/16, negative a. Let me get everything labeled here. The dotted line are your asymptotes, 1/8 and -1/8. Your halfway points are at 1/16, and -1/16, -3. This was a very easy tangent. Of course, maybe your line can be a little more nice than mine. All right, we are on the simplify and verify problems from 10.3. If you're watching this video at home, you absolutely need a fundamental trigonometric identity sheet to do this. All right, it will help you immensely. Let's start with our first replacement. This is going to be called a negative angle identity, and it's located on the bottom. Do you see anything on the bottom of your sheet that looks like what I just put in my green square? Yes, on the far bottom at the right, it's called the negative angle identity for tangent. It allows you to pop the negative out front of the tangent. The next thing we're going to do is replace this tangent. This tangent can be replaced with a sine over cosine. The identity I'm using is called a tangent and cotangent identity, the second one down. Now we have double negatives, which obviously will turn to be positive, and the cosines, which obviously will cancel. So everything we have left, the only thing we have left is a sine of x. All right, I actually think number 9 might be the hardest one on the whole entire study guide. I want to talk real quick about the famous, very famous Pythagorean identity. Sine squared theta plus cosine squared theta equals 1. If you watch the 10.3 day 2 video very, very closely, you might have heard me say you're allowed to rearrange these identities. Do you remember me saying that? That's what we're going to do right now. We are going to rearrange this identity to get something that looks like this. Any ideas how I could do that? You're going to subtract the 1 from the right-hand side to the left-hand side. But you're going to subtract the cosine squared theta from the left-hand side to the right-hand side. So you'll have sine squared theta minus 1 equals negative cosine squared theta. So it looks exactly like what I need it to look like. You're allowed to do that. You're allowed to rearrange it to make it look like something you can use. So what I've got in that purple square, I'm going to be replacing with negative cosine squared theta. X. I'm using x's instead of thetas. Now the whole idea with simplifying is you cannot work on the right. So the right's just going to chill out. I'm not going to do any work on the right. what I'm going to do with this cotangent squared theta is just replace it with cosine over sine. Cosine over sine. Now I'm making it squared because there's two of them. There's two cotangents. They're having two cosines and two sines. When you divide by a fraction, you multiply by the reciprocal, correct? That's what's actually happening here. I am dividing by this pink fraction, so I can multiply by the reciprocal of the pink fraction. The cosine squared x's will cancel, and I'll have a negative and a sine squared x left. And then it has been verified. That was not the easiest one in the universe, but once you rearrange that Pythagorean identity, the replacement kind of works. And you do have to know how to divide by fractions, I guess. We are on our last problem. This one is much, much, much easier than number 9. Does anyone have an idea how we could start? At the beginning. He's actually right. We're going to start by trying to replace the sine of pi over 2 minus x with something. You can find it under the co-function identities, the fourth one down on your trig sheet. It equals cosine x. Tangent, we're also going to replace with sine over cosine. And you're pretty much where you need to be at now, because the cosines can cancel, so you have verified that the left-hand side matches the right-hand side. Basically, it's like those geometry proofs. You just got to prove it and verify it works. End with a big check mark. Thanks for watching our video. It was 16 minutes and 50 seconds long, and good luck on your last quiz of the year. Here.